Hello, Math 3. Sorry I couldn't be there today. I had to run out to a doctor's appointment. What you're going to do today in class is you're going to watch this video and either correct any mistakes you have or fill in what you have. When you're done with this video, it's going to take about 20 minutes to a half hour. When you're done with it, you're going to take an open notes quiz. You can use your notes and homework. You're going to be flying solo on this quiz. When you're done with the quiz, obviously, you're going to turn it in to our sub. Please behave for our sub. I was kind of an emergency situation where you guys, I appreciate if you guys just not give the sub a hard time. All right, let's get through this. All right, the minor arc A to B measures 50 degrees. Right at 50 degrees out here. Right away, select all the true statements. Angle BCA right over here, would equal 50 degrees. That's not true. This would be an inscribed angle. This is going to come out to be 25, so that ain't true. Angle BCA measures 25 degrees. BCA, 25 degrees. That one's true. Angle BOA, that's a central angle, so that's going to be equals 50 degrees. That one's right. The arc from B to C, not passing through A, is 180 degrees. This arc is not 180 because B to O to straight across, that would be the diameter. So it's close, but that's a no. Angle CBO, and CAO are congruent. We can't tell. If A to O went all the way across, and the same thing over here, maybe, but the picture's incomplete. We can't assume that. So only B and C ended up being true. Problem number 2, chords AC and DB, they should have little segments on top, intersect at point E. List the 3 pairs of angles that have to be congruent. So there's a bunch of inscribed angles. There's more than 3 pairs. There's 4 pairs, to be honest with you. I'm looking at this. There's 4 pairs. But anyway, angle D is an inscribed angle. It would be half. Angle D is half of arc AB. Also angle C. If you trace angle C all the way across, angle C is half of arc AB. So whatever arc AB is equal to, angle D is congruent to angle C. These two are congruent. We can do the same thing going up and above. I'll go back to this red pen here. Angle A and angle B are inscribed, and they catch an arc up here. So angle A is half of DC, arc DC, and angle B is half of arc DC. So angle A is congruent to angle B. The last one, you got 2 pairs in here. You can pick either one, but you got vertical angles in the middle. So I'm going to go angle DEC. I need 3 letters here. DEC is congruent to angle AEB. All right. Problem number 3. The image shows a circle with diameters AC and BD. Are chords BC and AD not drawn? AC. No, I said that wrong. BC and AD. All right. Would they be congruent? Well, these are vertical angles, so they would have congruent arcs. And if you have congruent arcs and congruent central angles, then these do end up being congruent. Congruent arcs means congruent. I don't know why I didn't use the symbol. Congruent chords. Also congruent central angles. Those are all true. All 3 of those are true. All right, looks like that was all review from older stuff. All right, let's get to the stuff that we're currently on. A lot of tangents, stuff like that. In the circle K, segment AB is tangent to the circle, so we got a 90 degree right away. If the radius of the circle is 5 and the tangent is 12, then what's the length of KB? I'll call that X from here to here. Pythagorean theorem, people. 5 squared plus 12 squared equals X squared. This is a common right triangle, by the way. 25, 144 equals X squared. Add those together, you get 169. And when when you square root it, you get 13 for your answer. 13 is the answer right here. In the diagram shown, BC is a tangent at point C. If AB is 17, all the way across, if that's 17, and BC is 15, then what's the length of the radius of the circle? Let's draw a radius in. How about right here? Got a right angle. We're going to do Pythagorean theorem again. I think we did this one before. X squared, 15 squared equals 17 squared. So this is x squared, plus 225 equals 289. Subtract 225. Let's see if we subtract that. 89, subtract 20. I think it's going to be 64. And then when you square root that, you get 8. Square root that, you get 8. Just dawned on me that I need a calculator. You might hear me run and get a calculator in a minute. All right, pause it at any point you need to pause it. You want to get all these in before the quiz. Get all the answers kind of written down to kind of help you out, guide you on the stuff that I'm going to give you today. Determine if AB is a tangent. So we don't know if it's a tangent, so we're going to test Pythagorean theorem. We're going to test it out. So 8.4, square it. Now, 5.6 looks like it's only this part of it because 8.4 would be this part. The longest side has to be here. So 8 and 5 is 13, 4 and 6 would be 10. So this has to come out to be 14. That's 11.2. Well, now I need a calculator. How does that compare to 14 squared? Now, I'm going to be surprised. Just get my calculator. I'm going to be surprised if this comes out equal. Let's see here. Show my calculator work here. 8.4, square it. 70.56. 11.2, square it. 125.44. Uh-oh, maybe it will. Oh, forgot 14 squared. 196. Does this equal that? 70.56 plus 125.44. Look at that. Look at that. Even I didn't see that coming. Well, when that comes out equal, that means this is a right angle. So AB is a tangent. I did not see that one coming. All right, so everybody's thinking the same thing I am. Well, that means the other one's not going to be tangent. Huh? I'm not sure. If this part is 7.2, be careful. You're not going to use 7.2. These are both 7.2. And so the whole thing is 14.4. All right, so we want to know if that's a right triangle. So 14.4, square it. 12.3, square it. Does it equal 19.4 squared? I honestly don't know with all those decimals. 14.4, square it. 207.36. I'm going to add the other one right now. Plus 12.3, square it. This side comes out to be 358.65. Oh, what happens when you go 19.4 and square it? I get 376. So they're kind of close, but they're not equal. All right, so AB is not a tangent. AB is not a tangent. All right, find the segment length or angle measure as indicated. All right, so we got to find this little piece on the outside of the picture. If it looks like a tangent, you can assume it's a tangent. So we're going to put a right angle in. 3 squared plus 4 squared equals, we'll call it C. C squared. This one's going to be quick. We've done this one before, square root. So this whole thing is 5, and the radius is 3, so this is 3. So x, 5 minus 3, x has to be 2. All right, now this one, I believe this one, they put this one on a lot of tests coming up, so make sure we star that one. I've seen this one on tests. So the trick to this one is that rule we were talking about last class where, hey, I got 2 radii, actually we got 3, but we make an isosceles triangle, and so this corner and this corner are the same. Now we can assume this is a tangent, so there's a right angle, and we have to find this corner, that's x. So that 112 is an isosceles triangle. These are congruent, those two sides. So if you take 180 and you subtract 112, you get 68, and then divide that by 2. These are 63 apiece. Now what's important is that this one is 63. And now for the big triangle, here's the question mark, right angle, and 63. Now I'm going to figure out what this corner is by using the giant triangle. So if I go 180 minus 90 minus 63, you get an answer of 27. We might have had this. This feels familiar, like we use this problem on another day, on another worksheet. I mean. All right, let's do the same kind of work here. I got isosceles, so if that's 59, this is 59. And the whole thing is 90 degrees because that's a tangent line. So this one's easier. Go 90 minus 59, I get 31 degrees for that little segment. This is a right angle, so the 59 plus the one they're looking for has to be 31 degrees. Let's try another one. 15 is the entire side. This 6, just like that other problem, that 6 needs to be repeated here. So this length is 12. This is my x. That's my right angle. X squared plus 12 squared equals 15 squared. 144. 225. When I subtract, let's see, x squared is going to equal 225 minus 144, 81. That's what I thought. I was doubting myself. X equals 9 in this case. Told you these are going to go fast. They're all very repetitive. Stay with me. 7.8. They just want one radius, but what we're going to do is we're going to find the whole thing. I'll call it D for diameter. So 17.8 would be the hypotenuse. My right angle would be here. 7.8 square it, plus, we'll call it D. D squared equals 17.8 squared. Let me put this on here. A lot of decimals. 7.8 squared. 60.84. And D squared equals 17.8 squared. Oh, what's all those zeros? 17.8 squared. 316.84. Subtract this. Now this one's not familiar to me either. Let's see what we get here. Subtract 60.84. Oh, now that is familiar. That has a square root. You square root both sides. You got a button on here for square root. It's right above x squared, that blue thing. You go second, square root, 256. Get D to equal 16. Not bad. Not bad. All right, next one. It's another one of these. That's 50. That's 90. Let's find this corner. So I'm doing the giant triangle first. I'm sort of ignoring this line. So that's 90. That's 50. The third angle, 50. This has to be 40. And then this mini triangle in here is another one of those isosceles ones. This is 40, so this has to be 40. This is the question mark. So 180 minus 40 minus 40. Question mark's going to equal. That's going to be 100. 100 degrees. Now, you guys might be moaning and groaning, and I kind of agree. These diagrams are a little too small. I like doing all the scratch work on the diagram. I need to blow this up a lot more. And maybe not give us so many. We don't need that many. All right, next part. Did we do this? We're not even going to use the 17. I feel like we did this one. Oh, let me focus it again. Move my paper. There, look a little better. Two tangent theorem. This one is going to be congruent to this one, those two tangents. 11x minus 3 is equal to 10x. I'm going to subtract 10x. I'm going to add the 3 this way. I'm going to get 1x. See, I made my x's positive by doing it that way. 1x is equal to 3, and all we had to do was solve for it. And we can assume tangents on this. So this tangent would be congruent, same thing. 2x plus 48 equals x plus 48. That's kind of odd. Oh yeah, I can see what's going to happen now. Subtract 48. You get x equals 0. Kind of makes sense. If x is 0, you're going to get 48, and you're going to get 48. No problem. X is 0. Oh, a quadratic one. All right. So you got to do a little factoring in this one. This one is congruent to this one. X squared minus 2x equals 15. Subtract the 15. I won't put one this tough on your quiz. Not today. Not without a little more guidance. We do product sum. What are two numbers that multiply to be negative 15? I did 1 in front times negative 15. They add to be the middle number. So if you think about it, they multiply to be this, add to be this. It's going to be a negative 5 and a positive 3. And they go in my parentheses, x minus 5. Those are my factors. You set each one equal to 0. I got x equals 5, x equals negative 3. X equals 5, x equals negative 3. Next part. Circle O is inscribed in a circle such that it is tangent to points M, N, and P. If RP is 7, now remember, this one's congruent to that one. These two are congruent. Oh, I remember. They're going to put this on a test, by the way. They showed me that they're going to do this. This is sort of like a walk-around problem, not quite as tough. RP is 7, so this one's 7. RT is 17. Well, that's the whole thing, huh? All right, so RT is 17. That means we can figure this out. And SM is 5. So SN is 5. How long is ST? Oh, we can figure that out. So because these two are 7, those two are 5, we just got to figure out what these two are, and we're good to go. Well, if the whole thing is 17, all I got to do is subtract. This part has to be a 10, and I copy that down here. So ST from here to here, ST has a length of 10 plus 5, which is 15. This is going smoothly. You guys are probably going, man, slow down. You can pause it anytime. I'm just making sure I get the video in with enough time. Now, this is our walk-around problem, but with that extra 10, they made that a little bit easier. So we're going to do what we did over here. From each point, I got two congruent pieces. These are the same. Actually, let's just copy them. That's 8. That's 8. That's 5.5. 7.4s. So these two are missing. That's not going to be hard to find at all. If the whole thing is 10, and this part's 8, like we did over here, subtract. This is a 2. That's why it's so small, and that's a 2. Find the perimeter. The perimeter is adding them all up. So that's going to be 9.4 for the top. For the right, 12.9. You just use your calculators. Excuse me. It's going to be 13.5. plus 8 and 2 is 10. And add them all up. Now, I wrote them like I added the 2 on each side. You could do it individually. So it would also work if I just did, I'll start with this 8. If I go 8 plus 2 plus 2 plus 7.4, 7.4 again, plus 5.5, plus 5.5 again, plus the last 8. That's going to be 45.8 for the perimeter all the way around. All right, was that it for the... Oh. But wait, there's more. Aren't you kids lucky? Find the perimeter of the polygon. All right, so it's the same thing. The whole thing is 16.4. We'll figure that. That's 9. That's 9. 7.3. 7.3 congruent. Congruent. And these are congruent. All right, so if this is 16.4, and I subtract 9, I'm going to get 7.4 for here and for here. Now find the perimeter, add them all up. So these two would be 14.6. These two would be 18. And these two would be 14.8. 14.6 plus 18 plus 14.8, 47.4. A lot of tangent stuff today. A lot of tangent stuff. I'm thinking my quiz, I'm going to make it some tangents, but I'm going to make it with some inscribed angles and central angles and stuff like that. Line BD is tangent to a circle with a diameter AB. Yep, diameter is AB, tangent, so we got a right angle right here. Explain why the measure of angle BCA, what? That has 180 degrees here, so that's going to be a right angle. AB, well, I just said it, all right, they're both right angles. All right, both are right angles, or you could say 90 degrees. You could say angle C is inscribed, so it's 1/2 of its arc, 180 degrees, and angle ABD is where radius meets a tangent, which automatically means perpendicular lines, and it'll make a right angle. That had the look of being really tough. It was not. Might have been hard for you guys to follow, but it was kind of a simple question. 21, line AC is perpendicular, so that means it's going to be a right angle, to the circle centered at O, radius 1 unit, so this is 1. The length of AC is 1.5. How long is AB? Well, what we're going to do is find the whole hypotenuse. I'll call that C for Pythagorean theorem. So it's 1.5 squared plus 1 squared equals C squared. So 1.5, when you square it, oh, give me an answer, is 2.25. 1 squared, now you might think 2, but 1 times 1 is just 1. That equals C squared. Add those together. I don't need my calc. I do need it on here, though, because I'm going to square root that number. So all we're going to do, show the buttons for this again. Above x squared is square root, so second square root 3.25. And I get C to equal, well, I got to round it, 1.80. So it's 1.80 for the whole thing. Then I just subtract the radius, which is 1. So AB is equal to 0.80. I'll be honest, I don't like that problem. I don't know what teacher threw that on there. I don't like it. Number 22, PD is a tangent to a circle. Radius is 1. Oh man, they're liking these radius of 1. That's 1. That's 1. That's 1. Center is O. The length of PD is 1.2. I see that. But if that's a tangent, that's going to be a right angle. The length of AB is 1.7. Okay, that's a chord. Which point of the circle is closest to point P? Oh, here's our choices. Well, it's not A. Tell that. It's either B or C, right? It's either B or C. It's not D. So which one's going to be closer to point P? Now, just looking at it, I can kind of tell it's going to be C because of the angle, but I'm sure we have to come up with some sort of proof. I think we have to do Pythagorean theorem. So this is A to D to P. A to D to P. So this would be 2, 1 and 1. This would be 1.2. And then we're going to do the math work for that. Then we have a skinnier right triangle. O to D to P. Where this is 1. This is 1.2. And this is what we're going to solve for. So I'm going to do 2 squared plus 1.2 squared equals AP squared. This is going to be 1 squared. This is going to be 1.2 squared. This is going to be OP squared. All right, let me do a little math work here. 4, 1.2 squared, 1.44. That's the AP line squared, or you call it x squared. 5.44. I'm going to square root that. All right. Oh, I forgot to hit square root. Second square root 5.44. 2.33. That is rounded. That's how long A to P is how long. Now I got to subtract 1.7. I get 0.63. Now 0.63 is this little part right in here. So small. Over here, you get 1 plus, it's kind of like squaring 12. 1.2 squared. You get 1.44. B squared, 2.44. Square root it. Second, square root 2.44. Boom. 1.56 is the length of OP. 1.56 is the length of OP. O to P is 1.56, so this little piece is just 0. Got to take away the 1. You get 0.56, and that's going to equal CP. So it's close, but this one is a little bit shorter than that one, so C is closer. I am not going to quiz you on something like that. Boy, that was kind of a long video. That is almost a half hour right there. Here's what I'm going to do. I'm going to cancel the quiz. What I'm going to do instead is I'm going to tell the sub, I'm going to change my plan right here. Hopefully you're listening. You're going to fill this all in. You're going to check it. It's going to be 100%, and then you're going to turn it into the sub. So you're going to turn it into the sub, and once you do that, the sub will hand you the number 3 angle chase problem that we didn't get to last class. See if you guys can figure that out. The number 3 angle chase problem will be what you have to do for the remainder of class time. So this is going to take about a half hour, maybe a little bit more, half hour, 40 minutes if you have to hit pause, and then you turn it in. So I just changed my whole plan right here. Okay. If you have any questions, you can email me over the weekend. I will be around by the end of the day. I'm going to return after my doctor's visit. But if you guys have any questions, shoot me an email. I'll see it later on in the day. Please behave for the sub. Talk to you later.